Hello everyone, today we will practice using our skills to solve or simplify algebraic expressions. So here you can see the expressions. There are 10 expressions that I will explain to you, but I would suggest or recommend you to solve it first by your own. Maybe you can pause first the video, then attempt simplify this by yourself, and after it you may compare the result with the way I show you. Alright, let's begin with the first one. Number 1, given 4x plus 4 plus 12. So when we simplify, all we need to do is we're going to combine like terms. So when we say like terms, those with the same variables, so we're going to combine them. And those numbers without variables, we will also put them together or combine them according to the operation being asked. Now in number 1, they said 4x plus 4 plus 12. As you see, there is no other variable for x, so all we need to do is just combine the 4 plus 12. So we can just copy the 4x, then 4 plus 12 is equal to 16. So the result is 4x plus 16. Number 2. Negative 6 minus 5x minus 10x. As you observe, we're having this minus 5x and minus 10x. They are like terms, so we can combine them. So minus 5x minus 10x is equal to minus 15x. By the way, we need to write first those with variables, then those without, or the numbers alone. And then the negative 6 is only the number here, so we're just going to write negative 6, and that's it. The third one, 6pq minus the quantity of negative 4x minus 4x minus another quantity, negative 6pq. So we need to do first, we will take note of those inside the parentheses. So if there are 2 or more operations inside it, we need to do it first before we combine everything. Alright, so we're having negative 4x, negative 6pq, so no need for us to worry because they're only a single term inside the parentheses, so we can proceed directly by removing the parentheses. So you can have this 6pq minus and minus inside the parentheses, that will be plus 4x, and okay, just bring down negative 4x, and then again there's negative and negative here. We can make it as positive 6pq. Now this time, we can now identify what are those like terms. So as you observe, alright, let's have 6pq, so we are looking for a term with pq as the variable. Right? We're having 6pq here, so they're all positive, so all we need to have is just add them. So we're having 6 plus 6 is 12, so we're having 12pq. Then look at this, plus 4x and minus 4x, so this will be 0, so no need for us to write here, and the result is 12pq. Next, let's proceed with the fourth expression, 8 over 3p times 6p squared over 4. Always remember the operation. We're going to multiply. So when we multiply, just multiply all the numerators, or numerator times the numerator of the other fraction, and the denominator of the first fraction times the denominator of the second. Alright, let's begin. We're having 8 times 6p squared. Well, this is kind of big number, and there's another way for us to make it short. We can actually reduce it by, okay, or we can reduce it first, then we're going to multiply. So just like we're having here 3 and 6, we can make it as 1, and this is 2 here. And look, we're having here 8 and 4. We can make it 1 and 2 also here. And in this case, that would be smaller, so it would be easy for us to combine or multiply. Now there's another thing. Look, we're having p and p squared here, so that would be p on the numerator. Now what remains on the denominator is 1 and 1 here, so no need for us to worry about it. We're just going to have the numerator, so 2 times 2p is actually equal to 4p. That's the answer. Next, number 5. In number 5, 4 over 6x divided by 15 over 20. So when you're going to divide, again, we need to take note this division, because this is kind of different from multiplication. Okay, when we're going to divide, we're just going to copy the first fraction and then make it into multiplication, but we need to reverse this one. So this would be equal to 20 over 15. Okay, the expression now is 4 over 6x times 20 over 15. Now again, to make it easier for us to simplify, we can we can simplify first, or make the fraction into simple form before we multiply. So 4 over 6, we actually could make this as, okay, when we reduce it, could be 2, and this is 3. Alright, okay, let's try. We can have 2 times 20 is equal to, okay, 40, and we're having 3 times 15 is equal to, okay, 45. Oh, look, we're having 40 over 45, and we could actually, okay, reduce it to, okay, we can divide both the numerator and denominator by 5, so this would be 8 over 9. And this is the answer. Next, number 6. The quantity of 5p times q times 4 divided by 8. So again, first simplify those quantities that are inside the parentheses, or those terms inside the parentheses. Well, there's only one term here, because terms are separated by plus or minus, but here we're having times, so this is only a single term. So let's simplify this. So we're having 5p times q times 4. Alright, we're having 4 and 5, we can multiply it, so that would be 20, and p times q is pq, and this is now divided by 8. Or, to make it easier, alright, we can write this as 20 pq all over 8. Or, well, we could simplify this 20 and 8. Let me have other color. If we're having 20 and 8, this could be, okay, divisible by 4. So if we divide this by 4, this is 2. And this will be, okay, this is 5 on the numerator. So the result is 5, okay, we can have here 5 PQ over 2. Alright, let's proceed to the next one. Number 7, the quantity of negative 4 PQ times P divided by 8. So again, we are going to simplify those expressions inside the parentheses. So we have here negative 4 PQ times P is equal to negative 4 P squared Q. Now this is divided by 8. Now to simplify this, we can change its form into a fractional form. Right, you can have this P squared Q over 8, and negative 4 divided by 8 is actually 1/2. So meaning we can have here negative 1 over 2 P squared Q, or we can write it as P squared or negative P squared Q all over 2. Okay, let's proceed to number 8. The quantity of 3P times 2 and 1/6 divided by the quantity of negative 1 over 13P. Alright, so let's plan first when we're going to solve expressions like this. These are quite complicated, but well, we're only having here two operations, the times and divide. So meaning, okay, we're going to do the times, because we're having the MDAS, so we can have here 3P times 2 and 1/6 divided by this negative 1 over 13P. Alright, let's go. So let's have here, okay, this is equal to, okay, let's change this into fractional form first, but we have to simplify this one first and over this one. So we're having negative 3P times 2 and 1/6. So in this expression, we need to make this first into an improper fraction. So how could we do that? So let's erase this first. So negative 3P times, right, what is the improper fraction of 2 and 1/6? We're having 6 times 2 plus 1 is 13 over 6. And this is divided by negative of 1 over 13P. Okay, then let's simplify. Negative 3P times 13 is, okay, negative 3 times 13 is, this is 39, negative 39P over 6. Or we can actually make this simpler. First, we could have this, right, look at this. We have negative 3 here, and this is 6. So we could have negative 1, and this is 2. So we could make it as negative, right, we could make it as negative 13P all over 2. Then divided by, right, negative 1, or this is actually P over 13. Now the rule is that, again, this is divide, and they're having, both of them are negative, so negative divided by negative, so this will be positive, so this will become, okay, 13, sorry, the fractional bar is too long. Let's make, I will reduce it, 13P over 2. Again, they're all negative, so make it positive. Then we're going to make it into times 13 over P. Now as you observe, when you multiply, you're just going to multiply both the numerator and also the denominator. So we're having here, okay, 13 times 13 is equal to 169. Okay, this will be equal to 169 and over 2, because this 2 times 1. But look, how about the p? P is, there's 1 p on the numerator, there's 1 p on the denominator, so that would be equal to 1. Dividing it. So the answer is 169 over 2. Alright? Or if we make it into a mixed fraction, this could be equal to, okay, 169 over 2 is equal to 84 and a half. Alright, alright, this is 84 and a half. Now let's proceed to the number 9. X cubed y squared times x squared y divided by 1/3 x. Sorry, this is not x, this is 1/3 times 3x y. Well, this is quite confusing. That's why in algebra we're trying to not use the symbol for multiplication, which is looks like x, because it's confusing when we're using the variable x. But here, let's try this. So again, we are going to solve first those inside the parentheses. So this will be 1/3 times 3xy. Alright, this is 1/3 of 3xy is only xy. So meaning we're dividing this one. The given is, let's copy it first. The x cubed y squared times x squared. Okay, this is x squared y divided by xy. Alright, let's combine it first and let's make it into a fractional form. Okay, x cubed y squared times x squared y. So this is equal to x exponent of, alright, we'll just add this 3 and 2. So we're having x exponent of 5 and y exponent of 2, and this is actually having exponent of 1, exponent of 3, all over x y. Well, my fractional bar is too long. Let's change it, make it shorter. Alright, it's a different color, sorry. So we're having here, okay, x exponent of 5 divided by x. Okay, x exponent of 5, meaning to say we're just going to multiply x by itself 5 times and then divide by 1x. So meaning to say we're just having the remaining on the numerator, which is x exponent of 4, and y exponent of 3, or y cubed. That means that we're going to multiply y by itself 3 times and divide by y. So we're having y squared. And this is the answer. Alright, let's proceed to the last number, number 10. 4xy squared minus 5x divided by the quantity of negative 3y. So again, first we're going to apply, because we're having two operations here. We're having this minus and divide. Alright, so let's do first the division. Okay, so let's have this first. Okay, so let's have that. Okay, copy first. 4x y. Alright, this is squared. Well, actually we could also do this at the same time. I will do it one by one. So let's do first this negative 5x. So this minus 5x divided by negative 3y. Okay, so we're having here 4xy squared, so we could write it as 4 squared, so we could distribute the square to every element inside this quantity or the parentheses. So we could have 4 squared is 16, x squared, y squared minus, right, 5x over 3y. So actually this is negative 3y. We could make it plus because of this. Okay, minus here, so minus times the negative here will be plus, so this is plus 5x over 3y. Okay, and the thing is we cannot simplify this 5x over 3y, okay, since there's no common between 5 and 3 and x and y, and this is the final answer.